Hello everyone. Good evening, Professor. Today I'm going to explain about my final project. The topic of my final project is sentiment analysis for product purchase recommendation. The problem of my final project is that whenever we are going to buy any product, before going to buy, we actually analyze what is the rating of it and reviews of those recommendations. Once we are okay with that recommendations and rating only, we'll go ahead with buying the product or uh, recommending it to few other persons. So the thing is that, so here the issue is that few other people might only directly go buying the product based on the direct review ratings instead of reviews. So the issue what comes here that, so suppose I'm a customer giving the review for that product, I might give the rating as a 5, and but when it comes to review, I might tell that the product is not good, but I might given the rating as 5 because of that delivery and that package of the product. So for that, I might give a rating as 5. So because of these misinterpretations, the rating of that product might actually change and misleading to the people to buy that product. So we sometimes the issue is that we can't always read all those reviews. So this is also time-consuming process, and instead of reading all those reviews, we simply take that rating and see the ratings and go whether we'll analyze whether to buy the product or not. So that is the issue. So the thing is that so sometimes it might actually work, sometimes it might not. So for that, in order to reduce that issues, here what I thought of idea is that instead of directly going to the reviews, why not we analyze the text, and based on that text, we can able to actually make a model so that it actually recommend that product whether it is good to buy or not. That is the main aim of my project. So for that project here, I have taken two modules. One is natural language processing and deep learning to build that model. So for before going to that building that model, there is one concept called sentiment analysis. So the thing is that if we see the ratings, we can directly know whether the product is good or not based on the review. If it is 5, we can say it is a good product. But simply reading the text, sometimes we humans know. Suppose that if I'm the consumer, like I might write a review saying that the product is good, it is worth buying. So people might actually read that and say that yeah, it is actually good. So yes, it is actually good, so that they can able to buy. But reading all those, it might be problem. So in order to build a model so that it can read all the text and make it as a positive is actually not an ideal solution. That thing is that machines doesn't know based on the context that whether it is that positive review or negative review. For that, there is a concept called sentiment analysis. So sentiment analysis is nothing but based on the sentence or the paragraph, whichever we give, it can actually analyze the context behind that sentence which is given. So based on that, it can actually categorize the review whether it is a positive or a negative. So for that, we are using sentiment analysis here. So one more thing is that uh, using that sentiment analysis, we can actually use few of the models like naive Bayes and SVM model in order to build that such kind of model which we thought of. But the issue is here that these models, naive and SVM models, only try to get the few of the words instead of getting all the complete context of that paragraph. Suppose that if we say it is not good, so SVM and naive bias might treat not as separate word good as a separate word. So since good is there present in that sentence, it can actually treat that review as a positive. So such misinterpretations might happen. For that reason, we are going with LSTM, long short-term memory model, which is like advanced model of those naive bias we can think of it as, because it can actually remember the or context of the previous text we are given. So it is basically created using recurrent neural networks where it can able to store the previous, like remember the previous data also. So instead of directly getting the meaning of good, it can actually look at the previous word not. So by combining both the words, then it can able to detect it is actually not a positive review. So such things is useful for us. So for that reason, we are going with LSTM. So when it comes to dataset, I've taken the dataset from Amazon Review database, where the reviews were consisted between the range from 1966 to 2023. So in that dataset, there are few extra columns such as like timestamp, user ID, and some parent age number, all the things. Since we don't need all those columns, I've taken only the important one which we are needed for our analysis, such as like a rating, which are ranging from 1 to 5, and verified purchase. This is that thing that the data set which I've downloaded from the Amazon is actually consists of unverified reviews also. For that things, for that thing also, like for those reviews also, they actually stored those reviews in the data set. And one more is that text. Text is that main review given by the consumer or the user. And ASN is that like a unique number that is given to the every product so that they can able to identify for later purpose. And after getting the data, we have done some pre-processing analysis and visualization. There we can get to know that 10% of the data from the dataset is actually not verified data. So we are actually removed that data in our analysis, and then we converted the data from 1 to 5 range to two representation, because we can't simply using those five different categories, we can't say whether it is positive or negative. So for that analysis we are changing the data to two things. One is like a negative, which we mapped as reviews 1 to 3, and for positive we treat it as a 1, that is for 4 to 5 stars. And the one more thing is that here, since sometimes what we thought of like people might give rating as high and give review as a negative, but converse also might happen, because that people might actually give rating as low but give the product review as high. This is also sometimes contradicting. So this is also one of the case we have to think of. So for that thing, which I've thought is that instead of building one single model, I thought of building two models. That is that one is directly building the ratings given by the users, and another model is like automatically generating the ratings based on the text given by the user. So that can be done by the Bandai model. So here is the thing. Before building a model, first we need to do some pre-processing techniques, and something like converting the text into words and removing all the unnecessary context in that. And also, since the this is a text, we can't directly give that text to our model, so we'll just simply convert those text into numbers. And sometimes the text is too long, and numbers also sometimes will be too large that is mapped to the text. For that reason, we are like changing the length and all converting the words into numerical words. And then later we are changing that numbers, the data into two sets. One is for training and one is for testing. So before these reviews and the ratings, here we can see that we are giving the review and rating as two parameters to this processing reviews. The ratings might can be directly given by the user, or also can be derived by the vendor model, which we thought of. So here I can show you. So here in this data pre-processing step, we are actually using, yeah, sentiment intensity analyzer. This is yeah. This is downloaded from Weather module, which it can give the ratings as two values. If it is a positive, it will give return the value greater than 0, and if it is negative, it will give the value less than 0. So using this sentiment intensity analyzer, we are categorizing the review given by the user instead of taking the virtual ratings given by them. So by this we are having two reviews. One is directly given by the user. One is derived from the context review which they have written. Here, after getting all those pre-processing steps, here we are building the model, our neural network model, which consists of three layers. One is embedding, and second one is LSTM model, and third one is dense layer for that output sigmoid activation function. Using this model and using some error functions like binary cross entropy and Adam optimizer, we are building this model. For this model, we use five epochs to train the model. So after training the model, we found that the training and validation accuracy is almost high, greater than 92%. And here, if we see, we can able to find that using two different models. One is derived from the user ratings, and one is derived from the context they have given. We build two models. For those two models, we are given some sample text, that is the phone has amazing battery life and performance. Based on that, it actually given me as a positive review. So here, even if we see that the confidence is here, it is giving extra thing as like confidence also, with how much confidence that positive is actually the rating is actually positive. So one more thing is that if you go for the negative review also, it is showing that with 0.008 confidence, that is negative. It's not about if it is high confidence, it is confidence is basically what we can treat it as a threshold. If it is above zero point 0.5, we can treat it as a positive. If it is below zero point 0.5, we can treat it as a negative. That's how it works here. So that is my model, and here few of the there are few pros and cons of this model also. Uh, it can actually captures long range word dependencies, because sometimes instead of simply giving good and bad, some people write too lengthy context. Like the product is very good, so that you can able to use further like such kind of reviews they can. So simply we can't able to tell based on a single word it is actually positive review. For that it actually LSTM is actually good to use. And one more thing is that we don't need to manually pre-process all the text. Like tokenizer downloaded from the Keras is actually useful in order to reduce use in order to feature all those manual featuring techniques, and it actually generalizes well. And few of the issues is that since people might give too much long reviews also, suppose like some people might give 1,000, 10,000 words also. In such scenarios, a storage problem is there, and converting all this also it will be very cumbersome process. And also, even though for the data set I have, it actually took so much time in order to train the models. If it is a too much of large data set, it will take time consuming also. And sometimes it's very sensitive to the hyper parameters because of the text noises present in the data. And one more issue is that sometimes it might not able to detect all the sarcastic reviews also. That is also one of the disadvantage here. And for the future work, since here I built two separate models, those two can be actually combined together in order to build a new model. So that if any person give rating and review, taking both into consideration and finally give one a common rating, whether it is a positive or negative, it actually gives the better analyzing of the product. And few another thing a few of the other technology also we can explore like BERT and for deeper contextual understanding. And another thing is that this module is not only for product review. This can be actually applied to larger industries like uh, apps, or can be movie recommendations, all the things. If any company is building like releasing a new app, based on the reviews they can actually tell whether they can able to continue with the app or they need to change any modification, all those things. These are the things that we can derive from the model which I built, and these are my references. And if you see the working model of my project, so yeah, these are all the things. Here I'm not like running all this because it is taking too much time for that building these epochs. So I'll simply go through it. First, we included all the modules like for plotting and sentiment analyzer, and we downloaded the data, and again we've taken only the important data, and then we analyzed all the like whether any null values and all those things, and we found it visualized all whether the verified data is correct or not, and then we've taken only verified data. Then we actually analyzed like since there are too many product in that beauty products, we are choosing which are all having the high number of counts, and here we are doing the pre-processing, like converting the context into ratings, and also changing the ratings 1 to 5 to 0 to 1, like converting positive negative. So this is after converting. Here we are building more. Here we are building the model, pre-processing that review, removing all the unnecessary context and tokenizing everything. Here we are building the model, and here we are training it. So this is the evaluation step. So since it is taking too much of time for every epoch, it is taking around 570 milliseconds. That is around 67 minutes, more than 67 minutes. Oh, sorry, 363 seconds. That means around 5 to 6 minutes. So this is for single model given by the original converter ratings, and this is the derived sentiment analysis rating model. This is actually more accurate than that one. So this is the our final one. So here I can actually create a new one. So this is the phone as I am using battery and life experience. You know here, it is uh, actually- so for this review also, it is actually very good to buy. Give as a positive. So again, I'll go with the negative also. Okay. Here I've given it is not nice to buy. It is getting stuck whenever I'm using it. So it is giving it as a negative. So that's how the model is built. So this can be further extended to the memories and which I explained. So these are my references. Thank you.